It's a world of mystery. Do you really want to know?
Hello, my name is Data. Welcome back. Hope you're doing well. Are we in an interstellar cloud? Scientists may believe that we are. And is it causing a lot of the problems that Earth is experiencing on the magnetic side of our planet with the magnetosphere? Let's jump into what is the local interstellar cloud. It is also known as local fluff. Now that's quite a name. It's the interstellar cloud roughly 30 light years across through which the solar system is moving. It is unknown if the sun is embedded in the local interstellar cloud or in the region where the cloud is interacting with the neighboring G-cloud. So let's get into some more information. Let's start with this image. This is an artistic image of what scientists think we are floating through right now. There's the sun's movement to the galactic center and the stars Centauri, Sirius, and Proceo. So if we're moving through this local interstellar cloud, what could that possibly mean for us? Here's a different scientific image called the local bubble with Beta Canis Majoris and Antares, and you can see Betelgeuse on there, and the sun is in the middle. We are traveling through a highly magnetic area of space. This has been known since 2009 when Voyager 2 data suggested that the magnetic strength of the local interstellar medium was much stronger than expected against previous estimates. The fact that the local interstellar cloud is strongly magnetized could explain its continued existence despite the pressure exerted upon it by the winds that blew out of the local bubble. The potential effects on Earth are prevented by the solar wind, they say, and the sun's magnetic field protection that we have. This interaction with the heliosphere is under study by the Interstellar Boundary Explorer, which is a NASA satellite mapping the boundary between the solar system and interstellar space. I'll be flashing some images of interstellar clouds on the screen, and the sun is near the edge of this local cloud, and the scientists think we entered the region some point between 44,000 and 150,000 years ago. So we might have been in this for a very long time so far, and it's expected to remain within it. Our solar system is expected to remain in it for another 10,000 to 20,000 years. That's incredible. The cloud that we're in has a temperature of about 7,000 Kelvin, which is 12,140 degrees Fahrenheit or 6,730 Celsius, which is about the same temperature as the surface of the sun. The specific heat capacity is low because it is not very dense. The cloud that we're in is flowing outwards from the Scorpius-Centaurus association, a stellar association that is a star-forming region. In 2019, researchers found interstellar iron in Antarctica, which they relate to the local interstellar cloud. This local fluff that we are in spans an area of about 30 light years across. That's huge, and is actually part of a much bigger 300 light year wide cavern in space called the local bubble. It's very sparsely populated with atoms and hot gases. Ordinarily, the local fluff would be destroyed by the pressure of heated material in the bubble, but not this fluff. Scientists hypothesize that it could be the cloud's magnetism that saves it from destruction. They speculate on the origin of the local bubble and the local fluff and the nearby G-complex clouds. The gases in the larger local bubble likely came from a supernova explosion in the past 20 million years or so. And during these catastrophic events, Massive old stars blasted their outer layers and atmospheres into space at high speeds, sending out a bubble of superheated gases. A lot of people have been asking me why so many asteroids and comets. Well, they've always been around, but this cloud that we're in is definitely blowing like a wind. And who's to say that the strong magnetism that it holds doesn't have something to do with all the stuff that's going on? Maybe somebody in the future, in 10 to 20,000 years, when we pull out of this cloud, can tell us what kind of changes have happened in the solar system and to our planet. I guess only time will tell. Alright, that'll do it. We'll see you in the next video. Want you to have a great day, and as always, eyes to the skies. Bye-bye.
It's a world of mystery. Do you really want to know?
Hello, this is Data. Hope you're doing well. Last month, in the journal Nature Communications, an article was published discussing the first ever observation of a space hurricane. What is a space hurricane, and where did that happen? Somewhere on the North Pole, the top of the world, the center of the Earth on there. Happened to be a space hurricane. It was more than 620 miles wide and high in the sky. It formed in the ionosphere between 50 and 600 miles up. And the information was created using a 3D model of the storm. This is the only picture that we have. This space hurricane lasted 8 hours and it swirled counterclockwise. The researchers said that it had several spiraling arms snaking out from the center, looking a little bit like a spiral galaxy. They plugged the satellite data into a computer model, and they were able to reproduce the storm and figure out what caused it. They found that charged particles emitted by the sun's upper atmosphere, the corona, were to blame. The steady stream of solar particles and corona plasma is known as solar wind, and it moves about 1 million miles an hour. These space hurricanes must be created by unusually large and rapid transfer of solar wind and charged particles. As the solar wind reaches Earth, it encounters the planet's magnetic field. Earth had such a field because of the swirling liquid iron and nickel in its outer core, which gives rise to electric currents. The magnetosphere protects the planet from deadly radiation from the sun, but also retains a tiny layer of plasma from the solar wind. Solar wind usually glances off the protective sheath, but sometimes the incoming charged particles and plasma interact with either the trapped plasma or the electrical current generating the field. And such interactions create disturbances in the magnetosphere. This 2014 space hurricane was one such disturbance, and it is suggested that the interaction between the Earth's magnetic field and bits of the sun magnetic field transported on the solar wind, and that is what helped to form the storm. Usually these magnetic fields don't mix, but if they do come close, portions of the fields can get realigned and even merge, forming a new pattern of magnetic energy. This is what likely happened on the day of the space storm. An influx of solar wind formed a new pattern above the Earth's magnetic North Pole. The storm acted as a channel from space into Earth's atmosphere, funneling some electrons down past the planet's armor. This particle rain could have wreaked havoc on our high-frequency radio communications, radar detection systems, or satellite technology, because the charged solar particles that seep through the Earth's magnetic field can cause malfunctions in computers and circuitry on satellites, and also the International Space Station. Fortunately, in this case, no issues were observed.
It's a world of mystery. Do you really want to know?
Hello, my name is Data. Hope you're doing well. I'm about to blow your mind. We have water on our moon. Yeah, I can't believe it myself. How do we know this? Well, we know because NASA has run many experiments over the past decades, and one of the most important ones was called L-CROSS, Lunar Crater Observation Sensing Satellite. What they did with this rocket was they sent it to the moon, and they used the actual fuel container, sent it along. Usually they drop those back onto Earth, but they sent it up along with it, pointed into one of the craters that has not seen light in possibly billions of years because of the axis of the moon. They crashed this thing in there, and the sensor had about 4 minutes to gather a lot of information. And here's what they found. Upon impact, as the moon soil was ejected out of the crater, it was instantly vaporized by the solar wind and the sunlight and the heat. And what they found, as these items broke into their most basic materials, they found hydrogen gas, ammonia, and methane, which could be used to produce fuel for space missions. Large amount of light metals such as sodium, mercury, and silver were discovered. And as for that hydrogen found at the lunar poles, it does indeed belong to crystals of ice. And I will quote NASA here with their statement, that settles it. There's water on the moon, perhaps as much as hundreds of millions of tons of frozen water, enough to make it an effective oasis for explorers venturing away from Earth. This was a major discovery by L-Cross, and it caused a real change in thinking about the moon. No longer just a dry, dusty rock, this place holds a vital resource for human space exploration in its accessible crust. That ice represents fuel, water, and air that future surface facilities could harvest from the soil to support exploration instead of bringing it all back from Earth. So there it is settled. The moon has water, and any future exploration out there should have some decent water supplies. All they got to figure out is how to melt all that ice, turn it into purified water, and away they go. Alright, that is quite a story. Now you know the rest of it. We have water on the moon and other valuable resources. Alright, we'll see you in the next video. I want you guys to have a great day. And as always, eyes to the skies. Bye-bye.
It's a world of mystery. Do you really want to know?
Hello, my name is Data. Hope you're doing well. This is the information some of you may have been waiting to hear. NASA came out yesterday and said NASA scientists say a magnetic anomaly above our planet is going to split in half. I found that to be a very interesting headline, so I thought I would look into that. And yes, NASA is actively monitoring a strange anomaly in the Earth's magnetic field. It's a giant region of lower magnetic intensity in the skies above the planet. It's stretching out between South America and Southwest Africa. This is a vast developing phenomenon called the South Atlantic Anomaly. It's intrigued and concerned scientists for years, and NASA is looking into it now. The space agency's satellites and spacecraft are particularly vulnerable to the weakened magnetic field strength within the anomaly and the resulting exposure to charged particles from the sun. The South Atlantic Anomaly is likened by NASA to a dent in Earth's magnetic field, or kind of a pothole in space. It generally doesn't affect life on Earth, but the same can't be said for orbital spacecraft, which pass directly through the anomaly as they loop around the planet at low Earth orbit altitudes. During these encounters, the reduced magnetic field strength inside the anomaly means technological systems on board satellites can short-circuit and malfunction if they become struck by high-energy protons emanating from the sun. These random hits may usually only produce low-level glitches, but they do carry the risk of causing a significant data loss or even permanent damage to key components. Mitigating these hazards in space is one reason NASA is tracking the anomaly. Another is that the mystery of the anomaly represents a great opportunity to investigate a complex and difficult to understand phenomenon, and NASA's broad resources and research groups are uniquely equipped to study the occurrence. It's not just moving. More remarkably, the phenomenon seems to be in the process of splitting in two, and researchers this year discovering that the anomaly appears to be dividing into two distinct cells, each representing a separate center of minimum magnetic intensity within the greater anomaly. What this means in the future remains unknown, but evidence suggests that the anomaly is not a new appearance. Huge questions remain, but with so much going on with this vast magnetic oddity, it's good to know the world's most powerful space agency is watching it as closely as they are. Even though the SAA is slowly moving, it is going through some change in morphology, so it's important that we keep observing it by having continued missions, because that's what helps us make models and predictions. So we'll keep an eye on this, we'll see what becomes of it, and we'll see you in the next video. I want you to have a great day, be safe out there, and bye-bye.